Hi, I am Arib. You are watching my YouTube channel. Oil-filled transformers versus dry-type transformers. Introduction to transformers. Transformers are one of the most important components in electrical power systems. They are used to increase or decrease voltage levels and transfer electrical energy efficiently from one circuit to another through electromagnetic induction. Based on the cooling and insulation medium used, transformers are mainly classified into two categories: oil-filled transformers and dry-type transformers. Both types perform the same basic function, but they differ significantly in their construction, cooling methods, maintenance requirements, safety features, and applications. Understanding these differences helps electrical students, technicians, and engineers select the most suitable transformer for a specific application. What is an oil-filled transformer? An oil-filled transformer uses specially refined insulating oil as both a cooling medium and an insulating material. The transformer core and windings are completely immersed in the oil inside a sealed steel tank. During operation, electrical losses in the windings and core generate heat. The insulating oil absorbs this heat and circulates naturally or through forced cooling systems. The heated oil transfers the heat to the transformer tank and radiators, where it is dissipated into the surrounding air. This efficient cooling process allows oil-filled transformers to handle high electrical loads while maintaining acceptable operating temperatures. Functions of transformer oil. The insulating oil in an oil-filled transformer serves two important functions. First, it provides excellent electrical insulation between the windings and other energized parts. Second, it acts as a cooling medium that removes heat from the transformer's internal components. Commonly used transformer oils include mineral oil, silicone oil, and biodegradable ester fluids. Proper oil quality is critical because contaminated or degraded oil can reduce insulation strength and increase the risk of transformer failure. Advantages of oil-filled transformers. Oil-filled transformers offer several advantages. One of their greatest benefits is superior cooling efficiency. Since oil transfers heat much more effectively than air, these transformers can handle larger power ratings and overload conditions. They are generally more efficient and can operate continuously under heavy loads without excessive temperature rise. Oil-filled transformers are also widely available in very high capacities, making them suitable for power generation stations, transmission networks, distribution substations, and large industrial facilities. Another advantage is their relatively lower purchase cost compared to dry-type transformers of the same power rating. Disadvantages of oil-filled transformers. Despite their advantages, oil-filled transformers also have certain disadvantages. The most significant concern is the risk of fire because transformer oil is combustible. If an internal fault occurs or oil leaks onto hot surfaces, a fire may result. Environmental contamination is another concern because leaking oil can pollute soil and water. These transformers also require regular maintenance, including oil testing, oil filtration, moisture analysis, and inspection for leaks. Additional protective devices such as conservators, breathers, buckles, relays, and fire protection systems are often required to ensure safe operation. Applications of oil-filled transformers. Oil-filled transformers are commonly installed outdoors where adequate space and ventilation are available. They are widely used in electrical substations, power plants, transmission systems, distribution networks, manufacturing industries, and utility installations. Their ability to handle large loads and provide excellent cooling makes them the preferred choice for high voltage and high capacity applications. What is a dry-type transformer? A dry-type transformer does not use any liquid insulation. Instead, its windings are insulated using materials such as epoxy resin, varnish, or other high-temperature insulating compounds. Cooling is achieved through natural air circulation or forced air ventilation. Since there is no oil inside the transformer, the risk of oil leakage and fire is greatly reduced. Dry-type transformers are specifically designed for locations where safety, environmental protection, and minimal maintenance are important considerations. Types of dry-type transformers. One common type of dry-type transformer is the cast resin transformer. In this design, the windings are completely encapsulated in epoxy resin, providing excellent protection against moisture, dust, chemicals, and environmental contaminants. Another type is the vacuum pressure impregnated (VPI) transformer, where insulating varnish is applied to the windings under vacuum conditions to improve insulation strength and durability. Both designs provide reliable performance in indoor environments and harsh operating conditions. Advantages of dry-type transformers. The major advantage of dry-type transformers is their enhanced safety. Since they do not contain flammable oil, the risk of fire is significantly lower. This makes them ideal for installation in occupied buildings and public places. Dry-type transformers are also environmentally friendly because there is no possibility of oil spills or leakage. Maintenance requirements are generally lower because there is no need for oil sampling, filtration, or replacement. As a result, operating costs over time may be reduced. Disadvantages of dry-type transformers. However, dry-type transformers also have some limitations. Air is less effective than oil at removing heat, so dry-type transformers generally have lower cooling efficiency. For the same power rating, they are often larger and heavier than oil-filled transformers. Their initial purchase cost is usually higher, and they may not be suitable for extremely high-capacity applications where superior cooling is required. In high-temperature environments, their performance can also be more sensitive to ventilation conditions. Applications of dry-type transformers. Dry-type transformers are commonly used in hospitals, schools, airports, shopping malls, commercial buildings, residential complexes, data centers, underground substations, and other indoor installations. These locations often require equipment with high safety standards and low fire risk. Because of their clean operation and reduced maintenance needs, dry-type transformers are becoming increasingly popular in modern buildings and environmentally sensitive areas. Comparison between oil-filled and dry-type transformers. When comparing oil-filled and dry-type transformers, several factors must be considered. Oil-filled transformers generally provide better cooling performance, higher efficiency, lower initial cost, and greater power handling capability. Dry-type transformers offer superior fire safety, lower maintenance requirements, and greater environmental protection. Oil-filled transformers are typically preferred for outdoor utility and industrial applications, while dry-type transformers are favored for indoor installations where public safety is a priority. Selection criteria for choosing a transformer. The selection of a transformer ultimately depends on the specific requirements of the application. If the project involves high power demand, outdoor installation, and cost-effective operation, an oil-filled transformer is usually the best option. On the other hand, if fire safety, environmental protection, and indoor installation are the primary concerns, a dry-type transformer is often the preferred choice. Both technologies continue to play vital roles in modern electrical power systems and contribute to the reliable delivery of electricity around the world. Conclusion. Both oil-filled and dry-type transformers have unique strengths and applications. Oil-filled transformers provide excellent cooling, high efficiency, and large power capacity, making them suitable for outdoor and industrial installations. Dry-type transformers offer enhanced safety, environmental friendliness, and lower maintenance requirements, making them ideal for indoor and public environments. Understanding the characteristics of each transformer type enables engineers, technicians, and students to select the most appropriate solution for safe, reliable, and efficient power system operation.